back on the time schedule, and the next speaker is Mikhail. Please. So
Yes.
you may need to stop sharing your screen first.
Okay, now I think I can try to share. Okay. Do you hear me well, and do you see the right stuff?
I can hear you and can see your screen. It's not full screen yet. There it is. Please go ahead.
Now it should be fine. Okay, thank you. So apologies, I was not at the whole meeting. I'm traveling now and sometimes have difficulties in reaching out the place. And meeting, okay, now it's better. Fine, now I finally see my presentation as well. So that will be about IS4FIRES, stands for Integrated System for Vegetation Fires. I'll just try to give an overview of the whole system, and then maybe spend some time on current developments and future activities which are happening with the system right away. First, let me start from a pretty old slide. It's about years old actually now, but it's still very valid. So the system was born as based on MODIS with elements of Miser and Sofiev taken not in real time, taken offline. And the main product was first temperature anomaly when the fire radiative power was not immediately available from MODIS. But then it was switched to fire radiative power, and then that's the data set which is used in real time and in all applications. Miser was used offline for the plume rise parameterization, and that's what that one gets. And Sofiev was used for diurnal variation. And in the end, it all goes into first fire emission, fire-related emission, and sent to SILAM model as the next step, or available directly, or sent to SILAM model for plume computations. So looking at a glance, the system was born in 2006, and so just get a pointer. Yes. So in GEMS, which is a precursor start of big Copernicus atmospheric monitoring service, but after that it was picked up as an independent development with the Academy of Finland project, which was called IS4FIRES, which gave the name to the whole system. So it's about 15 years old. The key input data from the very beginning, they were, as I said, MODIS fire radiative power, and it remains like this now. But yes, MODIS is coming to its end, so steps towards VIRS, Lister, and maybe a little bit later, geostationary products. The system is global, so geostationary products create some challenges in implementing them into the system without destroying the balance of the fire inventory. As I said, there is a very strong link to SILAM, and we used it. SILAM possesses quite powerful data assimilation and source apportionment technologies. So what we did, we calibrated IS4FIRES emission factors against MODIS AUD and MOPIT CO data, and also in situ. But in situ were used mainly for comparison. They don't have sufficient cover, but these two satellites actually gave us calibration against particulate matter release and gas phase release. Now the system considers differently 5 continents. Each continent has 7 land use types, a pretty standard one. I'll show the chart in a second. The system distinguishes between flaming and smoldering, but I have to confess that this is a work in progress. So for now, it's just a fixed diurnal cycle. We do not yet implemented any reasonable algorithm which would distinguish between them on the fly. And other gases species, apart from CO, we just take them from Akagi paper, which was already referenced several times in those presentations I've heard. So basically, with these 2 calibrations against 2 satellite products plus the literature laboratory-based, cross coefficients give us the whole possibility to run the system for something like 20 species as the emission output. And this chart, it's cumulative chart, so the percentiles on the x-axis and land use contribution to total CO column. It's not MODIS, it's now it's MOPIT. And these are the land use types which we use. And the flaming and smoldering was separated, but as I said, the separation between them is now fixed. We did not see sufficient signal in 3 years, which we analyzed for MOPIT. A little bit more on diurnal variation was already mentioned today. We also saw it as a major phenomenon in the fire information challenge. So we derived it from Siviri firsthand to get some kind of reference point. Since the resolution of Siviri is pretty low, it was very difficult to attribute to really detailed land use types. So it was derived actually for just 3 major land uses: grassland, forested land, and mixture, as simple as that. And it was, of course, derived only for Africa, a little bit for South Europe, but not much really. The resolution there is really poor already. It's over 30 kilometers, if I remember correctly. So we went into refinement of this diurnal variation. It was refined with MODIS. First, like from kilometer to 10 square kilometers resolution gives more accurate land use attribution, and it gives global land use attribution. So we combined these two in a pretty direct way. So we took the shape from Siviri, but looked at the span between day and night, took it from MODIS. There was a problem with high detection limit of Siviri, so nighttime fires for Siviri are underestimated, and that is visible from this chart. So how to read this one? I'm sorry, it's a little bit busy. So these are all the continents. AF stands for Africa, AS stands for Southeast Asia, AS, rest of Asia, etc., etc. This open bars are the number of cases against which the fitting was made. So that's just an information about the data set for each type of land use. And that is a right-hand side axis. So that's a logarithmic scale, by the way. On the left-hand side axis is the ratio between daytime from local time from 11 to 13, so 3 hours, only divided by the mean ratio between 9 to 3 local time. So that's basically the overpasses. These are the overpasses for Aqua, and for Siviri or whatever geostationary, and here it's Siviri, yes. Here it is Siviri, so Siviri is blue and MODIS is orange. So they actually agree quite well, you see, for most of land uses, except for in tropical forest in Africa, there is a huge difference, and Siviri seem to be giving much higher ratio. And we believe that this is related to detection limit and ability of fire to hide behind the tree crones so that Siviri just stops seeing. At least for now, we think that MODIS number, which is like half of the number of Siviri, is more accurate. And it also, the same goes into tropical forests again, and again, it actually reproduces itself several times. So that's much about the diurnal variation, and it is fixed. Yeah, we do not assimilate it. And my comment to previous finding that nighttime FRP can be bigger than daytime, by default, we do not allow it. And that Portuguese case, when it was really the only way to simulate reasonably what happened with the situation, we had to break the system a little bit, allowing the different ratio between the fires. Already also said several times today, post-MODIS, MODIS is going down eventually. We still hope, last message from Arlindo was that we might still hope for some year or two of MODIS still being with us. But it's inevitable to go out of it. So with switching to VIRS, the process was started. We started more than a year ago. But we faced the problem that non-fire false alerts are very frequent, much more frequent than in MODIS. In fact, some estimates goes above 10% of small fires actually are not really fires. And the algorithm which we had for years for MODIS, which is just based on persistent fire approach, it failed. In fact, in VIRS, even once a week appearing fire, a couple of or maybe 5 times a year can be just a glint on some roof or some heated area. So the algorithm now is developed. It's much more complicated than what was for MODIS, but now it looks like it's working. Not yet operational, but at least we have it at hand. And the second problem was very technical, but pretty annoying. So the geolocation fields which I needed to get the clouds correctly collocated with fire or non-fire observations, which is even more important, they are actually of astronomical size. The total archive of VIRS now approaches 0.5 petabyte for geolocation fields alone. So we had to invent a new way of packing it and reach some couple of orders of magnitude of reduction, which actually made it feasible to operationalize. And this process is now on its way. SLISTER, that's the Sentinel satellite from Europe. There was another different problem, also very technical. The data were provided in some reprojection grid, which was not following the granule structure. So we couldn't really identify immediately the granules and had to reverse engineer the data to get what satellite actually saw and restore the initial granules. And after that, we applied the same packing as it was invented for VIRS, and it is in progress. But that's a little bit of technicality, but operationalization, we is waiting until we finish with VIRS and with packing. Last but not least, also was discussed already, but we need some fire forecasting model, especially when we are talking about air quality forecasting, or when we talk about gap filling in case of cloudy scene or something like this. For several years, IS4FIRES was undertaken to development of fire forecasting model. It's actually now running. I'll show a couple of examples about it. And its operationalization is pending until we solve the much more pressing problem with introducing VIRS into the game, because now the system is based on MODIS only. That's not sustainable. The key product which comes out of the system is the global 10-kilometer fire smoke forecast. Looks like what is on the right, and it is available from the CILAM website. I guess it's somewhere, cilam.fmi.fi. Sorry, I forgot to mention it. For evaluation against AOD, whether it's MODIS or IRONET ground-based network, we add particulate matter from other sources, and that is taken from the global air quality forecast, which is now at 0.2 degrees resolution, and plus the desert dust, which is another 10-kilometer resolution, 0.1 degree global forecast. So these three are mixed together, then we can compare. And that's one of evaluations. That's a full year. I believe it's 2019, pre-COVID year. So we didn't want to mess up with COVID times because anthropogenic emission evidently was not very correct. The left-hand side is bias. Whatever is green is a good hit. And the right-hand side is correlation coefficient. Whatever is yellow is also above 0.6. So it's a pretty decent hit. The important part is, of course, the equatorial Africa and the south of equator, where we have pretty substantial underestimation. And it is also the area where the maximum fraction of observations are considered as cloudy scene. So that's where the fire forecasting model is really needed to fill in these gaps. Correlation is not bad there. So you see we don't have any major problems there. It's at level of 0.7, 0.8, which is good. But the absolute level is pretty strongly underestimated. And we cannot do anything about it without breaking down the South Africa or, well, Northern Africa, that's sand and dust from Sahara, but South Africa will be destroyed if we change the coefficients to get equatorial Africa on board. And once again, correlation, we can't ask for much more than that. And the same phenomenon we see in South Africa, where the equatorial part is also underestimated, but here we also have some issues with correlation. A specific development and original development of the system was the plume rise. It's comparatively rare product. For now, I believe there are something like 3 or 4 models only working in that direction. And the comparison so far was pretty favorable for the IS4FIRES development, which also dates back almost 10 years from now. It's shown here on the bottom right side. 3 other charts are evaluations for 1D plume rise model, the dynamic model, or for 2 versions of formulas of Briggs. This system seems to be a little bit better. It's now used operationally in IS4FIRES for many years already, and we're actually pretty happy with it. And recently, it was evaluated. The paper just came in Atmospheric Chemistry and Physics in 2023, when the 3 methods were evaluated. So the Briggs 1969 from Saulo Freitas, the model, the 1D model, and that simple formula between. So we were actually pretty happy to see that it did not fail significantly anyhow before. Do you still hear me? My computer says that my connection is unstable.
Yes, we can hear you. Okay,
great. Thank you. And here, that's the time series of some specific fire. Whatever is red is IS4FIRES plume rise, and the yellow is the Freitas model, which overestimated, but Briggs formula was close. But I should say that there are these evident steps here. That's because the height is not what formula gave, but just the middle of the layer where the formula put the plume. So the actual number, of course, is with more digits, but here we see just a layer, which as it was in the model where it was tested. So that seems to be working pretty much okay. And it is significant. That was another message which was sent as well, that if we take this formula, let's say comparing to Briggs formula, the IS4FIRES sends noticeably a larger fraction of smoke higher up, and a bit less on middle altitudes, and leaves quite a lot in the boundary conditions. So there is some difference, and it's non-linear difference. So, and higher up, of course, that's what is long living. So it has some maybe even climate relevance, and what is below is the health relevance. With that system, we ran it recently. We ran it for the reanalysis for the MODIS era. Of course, we started from 2003 when both Aqua and Terra were available, and all the way down to 2020. And the upper map here shows the exposure of individuals, individual exposure, so-called, just basically mean concentration here. And there is nothing too fancy about that one. It's pretty standard what we are used to. But the bottom map actually was not that easy to see, easy to accept for doctors for whom we made that work. The work actually was published in Lancet journal in 2022 as part of the Lancet Countdown major paper. And the next one, by the way, Lancet Countdown, is the annual paper, middle of this month. We will have the release of 2023, where this approach was developed a little bit further. But what was evident from this reanalysis is that ups and downs in trends differ and actually intermittent in several parts of the globe, and in many areas the trends are not statistically significant. Significant trends are blue and red, and non-significant are brown versus violet. So wherever is violet, it's not statistically significant. In particular, in South America, we had downward trends, some significant, some not. North America upwards, etc. Europe was flat, despite a general and accepted consensus that fire danger is growing, and it is indeed growing, but the number of fires and the exposure of population doesn't seem to show the big trend. And yes, in oil region of Persian Gulf, things are going pretty well. They are growing. That's well seen. So now I think, how much time do I have? Do I have still 5 minutes?
Yes, you still have at least 5 minutes. Okay,
great. So just very quickly, I'll scan through a few more slides. The fire forecasting, which is now the biggest problem we are dealing with. So there we face that, first of all, it's natural phenomenon. So in principle, it can be predicted if we have meteorological information and all the parameters about the surface, but it is also regulated by anthropogenic force in triviality, but it actually makes it very difficult to predict. Comparatively poorly known, that's all triviality, sensitive to weather and climate. And the probability of ignition is anthropogenic. So I have to connect these two. And maybe if we look into this small area in Siberia, I chose it because it has low density of roads, which is here. Roads of Siberia, the red parts are cities, and every line here is a road. So they are separated at such large scale. And in 2010, when there was so a big heat wave in Siberia, we actually see fires along these roads. So basically where people can reach, we have the fires. Again, sort of triviality, but it makes it really difficult to predict the fires. And in the wetter year, let's say 2018, we still see these roads. There are fewer fires, but they are still along the areas where people can walk or drive. Okay, so I think I dropped this part right away, but this is important. We started from European challenges and also from Asia, and we see quite evidently all the borders of countries, or maybe some borders of some countries, and there is a dramatic change on fire radiative energy released over 20 years, left and right of the border or something like this. The same we see in Asia. So we had to go into gridded prediction. That was the decision when we moved on, and we constructed the statistical model, a machine learning approach, which takes the fire observations, the same MODIS, in situ in a few cases, but very rare. Usually it was MODIS. We looked into lightning data because this is the natural phenomenon igniting them. And that's a combination of in situ satellite and NWP models, which now produce lightning. We took weather data, of course, from NWP models, and then we split the whole set to training and did machine learning, and prediction, we went to predictive models. Comparatively standard set of tasks, but the non-trivial part was to use a very long and multi-step series of nonlinear transformations, which actually ensured that before we do the prediction itself, the predictors and predictants are both normally distributed. They represent stationary, they represent in ergodic ways, and they are dependent in near linear way. If we take the original data, none of these assumptions is even closely reproduced. But if we do quite a bit of data treatment, it actually goes through. Then we created the fire forecasting model, which actually implements all these multi-step procedures, and also uses, of course, SILAM to validate the prediction, and also compared it with MODIS. So as an example of what is here, this one, yes. So this is the whole period of MODIS, starting from 2000 all the way to 2020. And this is FRP for Scandinavia, so it is not very frequent fires. It's very challenging task for fire forecasting. And it is day by day, all these 20 years. Red dots are fire radiative power, the left-hand axis, as observed by MODIS. Blue dots are detection limit of MODIS. If there was slight cloud obscuration or it was at the edge of the swath, then the detection limit grows. So if the system predicts fire, which is lower than this blue dot, MODIS will not see it anyway, so it's not even an error. We don't know whether it's error or not. And these brown lines are the system predictions. So this is a very conservative setup of the system, so it was allowed to predict only major fires. And we wanted to see that these episodes when these fires were actually appearing are reproduced by the system. So you see there are some omissions, some pretty well captured. And this is the training period. For 15 years, the system was trained. And it was tested over the last 6 years. Over these years, we had in that particular grid cell, we had only one big fire event and the system reproduced it next to perfect. So the correlation itself is not too high, but this is day by day correlation. A bit different place. So now this is Central Europe, also 2 by 2 degrees. Yeah, we do not predict place of the fire, of course. The prediction goes to the region, which is quite large. Something like 2 by 2 degrees so far proved to be the only feasible resolution. And this is 3 years and a little bit more details how the system works against MODIS. The notations are the same. And the interesting part here is this one, where we missed the beginning of the season. You see there were several fires which were not captured by the system. But if we add lightning, and that's the difference between the two, we get these fires almost exactly. So it looks like they were because of thunderstorms. And as soon as we add them, things become better. And last but not least, as soon as the system was actually developed for climate scale predictions, it is autonomous, meaning that it does not require fire observations of previous day to be able to make the prediction. It can be run autonomously on climatological scale, and that's what we did within the project Exhaustion, which actually funded this development. We ran it on up to 2100, run 3 scenarios, SSP 1, 2, and 3, so the standard usual suspects. And what was interesting, actually, that the absolute strength of the fires was not predicted to become higher. The peak of fire strength were not really changing, but the frequency did. And the blue one, which is this 370 scenario, the worst case for now, as we think, it actually grew faster than 2 other scenarios. And according to this particular run of SESM, and if we believe the prediction of the fires, up to something like 2050, we don't have major reasons to worry, but after that, the situation changes. So I think I summarized now. So there is such a system, IS4FIRES, which is coupled with SILAM, and we heavily exploit this connection. In particular, we ensured the top-down calibration for CO and PM using the satellite observations, and resulting in 48, to be exact, different land uses, which basically 7 land uses over 5 continents, plus some games with Pete and so on. The system is used for daily global 10-kilometer fire smoke information and forecasting. We use fire radiative power. We don't use burnt area. We need it for forecasting purposes, so burnt area was no go. And there are some interesting developments. So first of all, the top-down calibration of emission factors and plume-rise formula. And the new frontiers, well, we have to switch to other satellites. We will be missing MODIS and the fire forecasting model, which should, when it gets operational, which should allow us to get rid of, finally, of persistent fires as the prediction in forecasting mode. I think I stop here. Thank you very much.
Thank you very much, Mikhail. Thanks for taking the time as well. Plenty of time for questions. I see that Mark has one there in the chat. Mark, would you like to ask your question?
Okay, yeah, of course. Yeah, hi, Mikhail. Thanks very much. Very clear and concise overview of IS4FIRES. So my question was, I think, just based on what you're showing for the fire forecast model and running forwards to 2100, have you thought about running it for the pre-satellite periods and comparing against? There's obviously some regions that have very good fire coverage, like Canada, Australia, going into the past.
Yes, in fact, I have to confess that I deleted that slide not long ago. I ran it for whole era 5. Yes, the run is available. I deleted it. I just felt that I have too many. But yes, it was done. Validation so far is only against MODIS. We did not do any validation against GFED for earlier years. We did not do validation against, let's say, AVHRR. It's all in the pipeline, but one at a time. We are really scared by disappearing MODIS, so we want to do that first. All the rest will follow. Oh, but great. Yes, we did that. We did that.
And I see Johannes has a question.
Johannes, you are muted.
Okay. Hi, Mikhail. Thanks.
Hi.
Very nice. Do you see a potential for modifying the forecasting model so that it can be used for the 5-day air quality forecasting on the previously observed fields?
Definitely, yes. There is a possibility for that. There is even a link for it. But once again, until VIRS and SLISTER are online, we will not be able to explore it. But yes, it's definitely the idea. There is the model as it is now. When it was developed, we put specific possibility for observations. The project which funded it was on climate scale. So, okay, we did climate first, but a simulation of recent observations, not recent days, something like recent weeks seems to be more appropriate, but yeah, it exists. And when we go online with the forecasting option, definitely it will be implemented. But I don't know how significant will be improvement. I don't have yet the date. So there is uncertainty.
Seeing any other questions or hands up yet? But I have a question maybe. So it was interesting to see the long-range projection of fires in the future and then becoming more frequent in the future. Are you able to get any information from the system about the ignition of those fires, whether that was lightning or human-based ignition?
The chart which I showed is without lightning, actually, because CSM does not predict lightning. And at that moment when we run that one, we did not have our own lightning yet. Now we have the scheme inside CLAM, which can produce lightning just out of convective clouds. But at that time, we did not have it. So that thing is exclusively anthropogenic. There is no lightning there.
Thank you. There's still time for more questions if anybody has one. And again, I'm very interested in these future fires because this is also part of the work we want to do in HTAP is look at future scenarios of long-range transport of air pollution, and having reasonable or good future fire emissions is important for this. I think there are some Earth system models that do have interactive fire schemes. Have you compared your future fire emissions with any of these?
Not yet. It's also in plans. There are very long list of plans. We really did not expect to get stuck on Virs and Slister for a year, practically.
Okay. I think I saw a hand up now from Christina, but it's gone away. I can't see it anymore. Do you still have your hand up? Would you like to? Ah, your mic isn't working. Then if you type your question into the chat, we can see it.
Virs false positives. Yeah. Okay. So the usual stuff, what we saw in case of MODIS, was that fire, which goes something like 40, 50 times a year, is a non-fire actually. It works also for Virs, but it removes very, very small fraction of actual non-fires. What we found really striking there is that even a roof which is tilted at some position of sun, satellite, and the view angle of the satellite can actually give a glint, and it is reported as a fire, but in fact it is a sun glint. We are used to sun glints over a sea surface, but in fact from tilted roof, it can come like this. We first didn't believe this. It took quite a while before we finally made the computations and calculated exact trigonometry and saw that indeed there is a very specific position of the satellite in some place where it all the time gives a fire as soon as it reaches that position, and it never repeats it in any other position. Then we had to mark it as a glint. And solar panels, yes, thank you very much. Exactly this. It's very, very often. So,
yeah, Mikhail.
Yes.
Oh, sorry, this is Shobha. I just wanted to let you know that Nova's operational Virs product has a persistent anomaly flag, which actually is based on all the locations of the big solar farms, the solar panel farms.
So far, yes, we know about that one. We have all the flags included, but it's not all.
Okay.
In fact, big hangar is as easily a false alert as solar panel. So Virs is very sensitive. It appeared to be extremely sensitive. And we removed something like 10–15% of small fires, but the default action, if we are not sure that this is a non-fire, we take it as fire. So it's we need to have like trigonometry calculations showing that it is a very specific combination of the angles. Then we remove it, or we see that it's a some area with like a big asphalt area, which can also be seen as fire, or a small lake where you can get sun glint and things like that. So a combination of the flags which are available from Virs, yes, plus this a little bit of computations brings much better. Wait a second. No, I don't have immediately the distribution. It's actually this false fires are well seen if you plot a histogram of Virs fires. There is a normal head as we are used to, and then suddenly a tail of small fires, which actually appeared to be practically all non-fire case. So that's what we believe now is a better estimate than just the flags.
Thank you for that. So Christina had some follow-up questions in her chat as well about confirming these false positives, which I think you just touched on there. But she also asked whether you'll be publishing the algorithm for that.
Oh yes, we publish everything as soon as we manage to make that thing running. Now, as I said, the absolutely first priority is to put Virs and Slister online, so that we are not we are not losing momentum if MODIS suddenly disappears. So as soon as that happens, there will be several papers. They are already in pipeline.
Great. So there's still a minute left for this discussion, and there is one more question in the chat that I can see from Jan Eof.
Yeah, I was just wondering, you showed the emissions for the last 20 years or something, and for Europe you started in 2003, which was a very special year because this was this very warm year, very famous year, but also a lot of fire emissions. So how was this trend affected by this year?
Thanks, Yanev. Indeed, 2003 was special, and it was pretty high year, if I remember correctly. And that's maybe one of reasons why the trend in Europe is practically zero, because we started from a very high number. But that actually is a problem with all these trends. 20 years is just too short period, to put it easily. And in that sense, yes, I agree that we don't really know what the trend is. If we start another year, it might be different, but that makes it statistically insignificant anyway. But what can be confirmed is that the fire risk, actually, that one has very strong trend, and it is statistically significant over most of Europe. In this new Lancet countdown, we calculated that map, and there is a trend of it, and it is practically everywhere significant. So there, 2003 did not really prevent from trend to appear. So in that sense, I do believe it is not a coincidence that we have zero trend in Europe. In fact, I can even say we went a little bit in depth into this question. It looks like the trend is zero because more and more efforts and funding is spent to mitigation. Mitigation, forest management, fire brigades, firefighting. So all these are getting increasingly sophisticated and increasingly expensive. And it looks like it pays off. But I don't have immediately the numbers to confirm it, but that's our strong suspicion for now.
Thanks a lot for that, Mikhail, and thanks again to all of the speakers in the session. That brings us to the end of this block. So now it's time for the break, and the schedule will resume at 16:30 UTC, so in about 13 minutes from now.